Hello guys, welcome back to the 11th tutorial. So as I told you about structures in the previous one, I said that there is a major problem with the structures and that is about the data security, right? So in this tutorial we'll be talking about classes. Now there are various things associated with a class and they are pretty advanced things, right? So I won't go into much of the advanced stuff, but I'll tell you all the basics about classes, right? So similar to a structure, a class is declared just like that with the keyword class, the name and an ending semicolon, right? So that's exactly like a structure, right? Just we have class instead of struct. All right, so let's make a few elements, right? Marks, maybe character name 20 something, right? So let's keep it 2. All right, so now there is a slight difference between a structure and a class. In the structure, all the variables which we declare here are accessible from the main function using the object, right? So suppose I write student1, right? So if I go ahead and write st1 dot marks, I can access it, right? In case of a structure, but in this case this statement is not valid, right? It will show an error. You can go ahead and compile and check yourself, right? So the problem is this variable is private, right? So there are three types of specifiers, right? So one is the public, one is protected, and the other one is private, right? So the public elements are accessible everywhere in all the functions, right? The protected ones are used exclusively while inheritance. I'll tell you about inheritance in a while. And the private ones are basically can be accessed only using the member functions of that particular class. So by default all the members in a class are private, whereas all the members in a structure are public by default. So you can access the structure members anywhere, but you cannot access the class members like this. One more thing, apart from the variables, we can also have functions inside a class, same like we can have them in structure, right? So we can go ahead and we can write get data, one function, or maybe we can have another one as put data. Now again, as I said, by default these will be private. So if I try to access them using st1 dot put data, this will throw an error, right? Because it cannot access put data because it is a private function. So what we do is we go ahead and we write public. Whatever follows the public are public, have public scope, right? Now again, you can define these functions right here inside the class. I'll define one inside the class and one outside the class, right? So we can go ahead, we can type enter the details. So we can again use gets for name. We'll need to include conio for this. Mark, again we can see in mark. Now we don't need to specify the name of the variable here like st1 dot name, because this is a function which will be used by this object, right? So when we call it as st1 dot put data, it knows that it has to store it in st1 dot name, right? All right, so that's how you define function inside a class. Now what if I want to define it outside the class, right? So we have to specify the scope, right? So we'll write void the name of the class, then double this, and then we'll write put data. So what this operation, what this means is it's called scope resolution operator, right? So what this statement means is there is a function called put data which is for the class student. Now we can have several classes in a program, right? So suppose we have two functions named put data in two different classes. So how does the compiler know that which put data this definition belongs to, right? So that's how you resolve that problem. You tell the compiler that there's a class called student and this particular definition of put data belongs to that particular class's function, right? So again we can go ahead, we can write cout marks name is this and marks are this. Now let's I have made an object. Now this particular thing is called an object, unlike structure in which case it is called a variable, right? This is called an object. And let me just first show you how this program runs, then I'll tell you how to I'll tell you about the theoretical concepts, right? So first we'll need to take data, right? So we'll first call the get data function, then we'll call the put data function. All right, let's go ahead and try it out. Right, name is Akib, marks are 56. Right, there we go. Name is this, marks are 56. Exactly. Alright, so now let me get to the theoretical part. Compilers and interpreters are both basically check your program for errors, right? So compilers, what they do is they actually compile the entire program in one single go, while the interpreters do that line by line. So compiler first compiles everything in the program and then tells us if there are any errors. While interpreter, if there is any error in a particular line, it stops right there. It indicates the error and stops right there. Right. So after that, there are various programming techniques. Right. So it starts from right. So the first programming concept was it was executed line by line. The control was not shifted anywhere else. It started from the first line and it went on to the last line. After that, slowly the if kind of statements were developed so that control can be modified according to a particular condition. Then came the looping concepts and everything, right? So slowly after several years of programming, what we have today is this. Actually, this is also not the most modern thing out there. There are various advancements. So let me go ahead and tell you what a class and object exactly mean, right? You consider any real world object, right? So what a real world object can do, let us suppose maybe a tree or something, right? So tree has roots, tree has leaves, tree has stem, and all those are its parts, right? And what it can do is it can shed its leaves, it can regain its leaves, and those are its characteristics, properties. Or suppose we consider a bike, right? So there are various parts like handle, seat, and etc. And what it can do is it can start on its own, it can accelerate, it can brake, right? So what I'm implying is that there are a few characteristics and there are a few properties, right? So the characteristics which make up the actual body are the variables and the properties are the functions. That's how the real world objects are represented in programming, right? So a class is basically the blueprint of an object. So if I say class student, I mean a particular student, as in a real world student, right? So what a real world student has, a real world student has name, a real world student has marks, and maybe the academic history or something like that, address, phone number, and all. And what it can do is I can write various functions to calculate the total marks, the average marks, and all that. So that's how a student is represented in a programming language like C++, right? By using a class. Now there are various concepts associated with a class. Alright, so class is basically the major difference between C and C++. C++ is basically C with classes. There are few things like abstraction. First concept is abstraction. So what abstraction basically means is a blueprint of something which has some functions of its own, right? So that's what we do here. We have a blueprint of a student and the functions associated with it. So the user just cannot write any function of its own, right? We have given some predefined functions for him to use. So as of now in this program, the user can only use two functions. One is get data and put data, because only those two we have made available for the public, right? So the public can access only those two functions. They cannot access the marks and name directly. They can do that only via these two functions, right? The next concept which comes into play is encapsulation. Now encapsulation basically refers to the binding together of a data, right? So suppose we are riding a bike, so we don't actually know when we switch the gear by holding the clutch what actually happens, right? We don't know the inside machinery stuff. What we know is when we press hold clutch and shift the gear changes, right? That's all we are supposed to know. So that's the basic concept of data hiding and encapsulation. Only whatever is required for you is visible to you, right? So in this case, we only the functions are visible to the user, right? How the data is stored and how much memory is allocated for that data and all, that is not required. Just like in a case of calculator, you don't know how the actual calculation takes place, but you only know to give the inputs and get the result, right? That's what we want. We have no interest in knowing how it actually calculates the stuff, right? So that's what data hiding and encapsulation means. Another concept is polymorphism. Now polymorphism is basically one same function having different outputs according to the different inputs, right? So suppose we have a class called bird and we pass a function called seeing at night. right? So all the other birds will return false, but the owl will return true for that function. So that's what polymorphism basically means. One same function, different outputs depending on the inputs, right? So those are a few concepts associated with object oriented programming languages, right, like C++. And class is basically the implementation of all those concepts into programming, into C++, right? Alright, now there are a few other advanced stuff in class like inheritance and all, which I'll not show you in this tutorial, but I'll just give you a hint of what that actually means, right? So inheritance is basically like one class can inherit its properties from another class, just like real world inheritance. You inherit some of your characteristics from your father, some from your mother, some from your grandfather, like that, right? So exactly what we can do is we can create a class called vehicle, right? Vehicle, we can give its properties like it has some wheels, engine and all. And then what we can do is we can go ahead and we can create another class called a car. So we can narrow down our characteristics to vintage or SUV and all. Then again we can create another class for a particular car. So suppose if I say Tata Fortuner, right? So what I'll do is I'll inherit the properties of vehicle as well as SUVs, and then I'll add its exclusive features to the class of a Fortuner, right? So I don't need to define it as a vehicle again, because I can directly take the properties of vehicle and put it directly to that class, right? So that's what inheritance basically means, taking the properties of a predefined class and specifying only the extra properties which it has, right? That's basically what the class concept is. You will mostly use class concepts for professional programming. So that's about it for the advanced stuff. From the next tutorial onwards, what we are going to do is we'll start making our own snakes and ladders game, right? So go ahead, try out a few codes. I've given them in the sheet, and I'll see you guys in the next one then.